There we go. And we are live. Everybody, it has been a while since I've streamed. Turn that down a little bit. There we go. That looks about right. So, last time I streamed, I think I was still working on this idea, but I don't remember if I said it at the end of my stream, but I definitely posted about it after the stream. That I was kind of just giving up on the idea of this language that I was working on. I was like, you know what, it's gonna be too much effort. I'm just going to basically, you know, I'm just gonna for any of my projects just use an existing language and just it's just not worth it. Unfortunately, I found I just straight up can't stop myself from working on it. And I kind of just want to make cool scripting languages, so I might as well just enjoy doing that. So that's what we're doing. I've been working on it for a bit off of stream, obviously, and it's currently in a state where we can actually compile a Hello World program. It is definitely, it's not even an MVP yet, it's just it's showing off the concept. So if I run the Hello World script here, you can see we import some C libraries, and then we define a main function inside of a C object, and then we link it, give it an executable name, and then I just print out the string success, because it doesn't really matter what we return here, but it does return success because that's all it knows how to do. But it does compile the binary there. So if we run build hello world.exe, prints out hello world. So all of this does, even though I'm taking a lot of shortcuts in a lot of places, it is technically working. And just to prove that it is actually working, instead of saying hello world, let's make this say hello chat. Just like that. We'll run the pillar script again. That's what I'm calling this language. I'm calling it pillar. This is not really the idea behind that is that it's not an entire standalone language. Its main purpose is to emit and compile other languages. So it's basically a really fancy macro system. I just thought of the idea of it being a pillar that things are built upon. I don't know. Anyways, after running it again, we can just do that, and look, it prints out hello chat instead. I do think that, okay, my webcam is not covering over that. Should probably here move this up there, that way my command line isn't being covered too much. Yeah, change this back to hello world, run the script again, and then yeah, it just says hello world again. So I've proven, well, not even proven that the concept really works. I've just shown this is the shape that the idea is taking, and now we need to take it from this bare minimum, get from beginning to end, to instead an actually viable thing that I could make some simple programs in, or complicated programs in. Ideally, this makes it easy to make complicated programs. So ideally, this becomes something I can make complicated programs in. So what is currently preventing it from being viable, I guess? I guess we can just put a to-do list right here at the bottom of the README. Won't hurt anything. Okay, thinking about it right now, there's a ton of different things that are kind of just hard-coded. Like, this return statement doesn't actually do anything. In fact, do I even need it in there for this to work? No, I don't. Runs just fine without it. Ideally, this should actually, you know, this should actually be required. Who has been your main focus with C? Mainly compiler stuff? So, been messing around with C as the idea of a lot of the libraries that I want to interact with are basically just like operating system APIs and whatnot. Not APIs, application programming. Yeah, APIs. And C is just the cleanest way to interact with any of those because it's just the interface that everything makes. And I want to have as much control as possible over those interfaces. But the problem is C is just really lacking in a lot of the things that I want. Like, at the very least, I want to have a clean interface for just, like, generic lists. That's honestly, like, one of my larger issues with C is that I can't, like, create a generic list type that has utility functions for dynamic resizing. And I know you can do X macros for that. I hate X macros. They're terrible. They're a workaround. Anyways, I also really like doing metaprogramming, like a lot of metaprogramming. I just want to write code that can go, if this type is a thing, or like add this member to a type, in a very, like, I think Zig is able to do stuff like this. Allegedly, what's the name of it? Allegedly Jai might be able to do this, though the one video I've seen going over Jai's metaprogramming was just string manipulation, like Rust macros, basically. To be fair, it was a better interface than Rust macros, because you don't have to manually parse the input from tokens, but it's still, like, string manipulation just kind of sucks as a macro system from the experience of actually writing the macros. So what this project is I want to write C, but I want to have really good macros. So we're writing an entire scripting language that basically reduces to C, but it acts as the build system and the macro system, and then we get compilable C as or just fully compiled binaries from C code as the output. Now, if we look at my emit file, we can actually see, like, here's the C that it emitted. It's definitely not pretty. I didn't realize that we're not new lining after the forward declaration for printf, but like, it works. And then here's the object file it emits and whatnot. So you can see this interpreted at compile time language just maps pretty much one-to-one onto the build pipeline of C for the moment. I'm thinking that I might also make it be able to emit JavaScript, because it's like, okay, I have my really good macro system. What if I made this just work for anything I want to build in the future? If it can do C, it can do anything native, it can do JavaScript, it can do anything web. At least that's my opinion, and hopefully I never have to interact with iOS, because they... iOS. And they'd want me to use Swift or Objective-C, which is different from everything else. So Mac gets left out because they want to be different. But yeah, so C object, this maps onto that object file. So we emit basically this as that C file, and then it gets compiled into an object test.exe is kind of, this is like handle to that object file, and then when we call this link underscore exe, link executable function, it just links all those objects into this executable here. And then this is not needed at all, that doesn't do anything. I'm undecided what to do with the return value of the like root script yet. I do know that like module scripts, I want them to just like return like, okay, if I were to create a second like module file here and then link to it from somewhere up here, I'd want its return to basically be one of these C object things. But yeah, that's what we need to figure out here. Well, most of what I need to do right now is just make it a lot easier to work with. So if I go to my standard library, or even the Clang emitter, so I'm just literally doing command line calls to Clang to do the actual compiling. I'm not building much of a compiler, it's basically just a fancy macro system. If I go here, the code is... It's harder for me to read right now because I have the text blown up a lot larger so it's visible on stream. But yeah, there's a lot of stuff here that I need to make simpler. Like when I'm registering intrinsic functions are really hard to write manually because, well, I have to basically do all the VM stuff myself. Like here, I have two different argument types for functions, for one thing. Writing this on NVim on native Windows instead of... Yes, so I'm just having NVim inside of PowerShell. Makes it easy. But, yeah. So if I go here, anytime you see square brackets here, this is actually a function call. This isn't an object. It is creating an object, but the way that it creates an object is that this is a function and it's getting called with these named arguments. So I don't know what to call the VM for this. Right now it's entirely dynamically typed. I want to make it like partially typed. See, I tried Vim and found that it had bugs, especially when trying plugins. Can the same be told about NVim? I haven't had too many bugs. I don't know if I've had any, like... I've had occasional bugs and whatnot, but it's not been terrible. If you want something that basically just works all the times, get a JetBrains editor, and then put a Vim plugin on that. That's what I do for work. But yeah, so okay. I guess to start filling out the to-do here, because that's what I need to do. I need to figure out what I actually need to do, because there are a lot of things to do. One of the main things I want to do is make it easier to validate and unwrap intrinsic function arguments. And the reason why this needs to be easier is because right now every single function has two different argument types. You can either do array args, which that's your standard function calling convention where you just put in curly braces and then a list of arguments that are comma separated, and you don't specify the names of your arguments. Now I also have object calls, which this basically just looks like an object initializer. I think I just talked about that. And it doesn't do any abstraction on the VM side to turn those both into the same type of function call, because, you know, I want to be able to do array-based function calls, and I want to be able to have just entirely named arguments that don't have to be specified ahead of time. But the problem is with this, I have to do, like, okay, what type of arguments do I have? Do I only want to accept one type of argument, or do I want to accept two types of arguments? I don't know. So for intrinsics, it's just like I'm choosing one or the other. and I don't have like a clean way to. Ooh, that's another one. We need to handle runtime errors better. To make an error handling system. This is probably the first thing I need to do, because every other system needs to feed into the error system. The idea with this is, since this is a dynamically typed language, runs at compile time, and then outputs an executable, that means runtime errors in the compile time language are our compiler errors. So we need our runtime errors to be as descriptive as possible. Because the more descriptive our runtime errors are, those are just our compiler errors. They need to be good. Yeah. Okay. And then when we make it easier to validate and unwrap intrinsic function arguments, one thing we're going to need is we just straight up, I need to figure out the type system. This is the virtual machine is entirely dynamically typed at the moment, and that's fine, because I want a lot of the features that dynamic typing gives me, because at compile time, until we actually emit objects, like, everything is dynamic, right? Like when I'm messing with a type, until we actually emit that type, it's fine if like its members change, it's fine if it, like, we add stuff to it, remove stuff from it. It's only like in the finished thing that we want types, and we do want those types. Now in the middle, while we're doing while we're compiling, we do still want to be able to verify types, because there's just so many really simple bugs that you can fix by having a type system. Now we can have type errors at compile runtime. We just need to be able to validate those. So need to fully implement the type system. There is so much that goes into this, like, so much. And I keep flip-flopping back and forth on how the type system is, like, truly going to work, but I think we do need errors of a sort before we implement the type system. Yeah. Then so after we implement the type system, or partially implement the type system, let's say we need to sufficiently implement the type system. That's probably the best way to put that. Then we need to create a standardized way to check types. Standardized way to check types easily. And this standardized way to check types is what will feed into the validation system for those intrinsic function arguments. So kind of each one of these feeds into the next step. What else do we need here? I also think I need to need to have wrappers for yeah, we need to have wrappers for calling functions from host code. Because if I'm writing like my language, all I need to do is like a function called signature, right? Very little amount of syntax, but if I'm actually writing code here, it is really inconvenient to do basically anything I want to do here. Because there's just a ton of boilerplate I have to write to interact with all the types. And maybe that just means I need to move my standard libraries over just into the script and then just kind of bootstrap from there. That's honestly entirely possible. And then just keep like very few like absolutely base standard library functions. Keep those few base functions actually in the existing what am I saying here? Yeah, basically, do I make it easier to interact with my language from Rust, or do I just write stuff in my language and make it like actually usable? Do this or bootstrap. Honestly, bootstrapping the standard library is what makes the most sense here. Simply because, yeah, then I'm already working with the language and making it better. So with that, I probably need to make a way to either embed pill in Rust, pillar, or ship it with the honestly, like a pill macro is probably, yeah, a pillar macro is probably the way to go here. Oh, it's going to be a pain. So I'm thinking about like this bit here. If I make a way to embed the scripting language in Rust, how ludicrously inefficient will that be? Like, I'm thinking like inline assembly, like I just do like PIL here, like Peller, pass in the virtual machine or the execution. Like we pass in the execution context, and then we just write our code right there. Just calling things. I guess I would need a way to pass in arguments here and basically turn it into a function call. But yeah, that's a pain. And probably very inefficient, because what the macro would basically do is it would parse the tokens here just like as a string, basically. Or maybe I would just even have it be a string, but that's really, it's not great. No, it kind of has to be a string. In any case, basically, I don't think we're doing inline pillar anytime soon. So yeah, I think what we do is we have a number of files that I think Rust has a like an import macro or an include macro. Yeah, it has an include string macro or an include bytes macro, both that will embed strings into our those would both include strings or bytes into our binary that we could just use in code without having, like, yeah. So that's probably what we're gonna do here. Is we're gonna have just like a pill folder here. And then this is going to be like the pillar code. What I probably want. I don't know if this is gonna let me do it, but okay, so here's our standard library. If we add in a... Yeah, we can just add in pillar files here. I don't think I need a separate directory here, but I could add in... Like, we could add in a pillar file right here. And then this is where I write all of my standard library code for pillar. And hopefully for the standard library specifically, I guess there's a difference between a core library and a standard library. Because I can't run pillar files without a standard library. So I'm not quite sure how to bootstrap this here. Anyways, I will figure that out when I get to that point. The other way that we could do inline pillar macros is basically just write a macro that evaluates to Rust function calls that are interacting with the virtual machine. Which would essentially just be a wrapper for what I'm already doing here. And I don't want to do that. because it would be a lot of work. Okay, so we need to basically just have better bindings for interacting with the VM. Got that. And at some point here, I'm gonna have enough of a standard library that I won't have to be manually doing, like, right here. What am I doing right here? Set current function. Current function. VM string from string. Yeah, right here, what I'm doing is literally grabbing a string member, appending it, creating a new virtual machine string, and then adding it to a list of arrays. But like what I do up here is like literally taking a string, appending it as raw buffers, and then like putting it back together. And even this is like with some bindings, because this VM string from string is doing the conversion from this into like the slice type here. A lot of manual work. Need to make this be less work for it to actually be viable. And then here, need to make return statements actually work, and to make return statements actually work, need a way emitters. Okay, need to design the way that emitters decide I need to design the way that emitters decide if they're emitting code or not. Like, are we emitting a call to a function? I was gonna say example. Example, are we emitting a call to a function and then turning a placeholder turn value, or are we a placeholder return value, or are we just evaluating the function in place, basically? And then need to be able to handle branching in emit versus evaluate situation. Basically comes down to if we are emitting the current function or not. Need to be able to decide when to what was I going to say here? Need to be able to decide And then my brain went on a tangent about, like, I guess struct instantiation, but that has nothing to do with what I was about to be able to handle. Branching emit versus evaluate statements or situations. I don't know. Need to be able to decide, basically. Where to actually start? I guess the error handling system is where I should start here, and then get rid of every single one of these to-do statements. I wish this worked. It'd be really nice. Expected string got a function. There's a lot of work to be done on this code writer class. Like a lot. Most of the work to be done there. But we should probably get error handling working first. So, we have the thing working. Now we just need to make it so everywhere here where I have a to-do statement, this just crashes the program because I didn't want to have to deal with. This is just a... Yeah, this is just a wrapper to panic. Oh, that's funny. Ergonomic error handling system. So now this comes down to... Go to the module here and then look at all these errors. It needs to be significantly easier for me to interact with the error system than it currently is. Because right now, it is a lot of effort to write an error. Like, a lot. Way too much. And if it's too hard to write errors, I don't. And we need to have a lot of errors. We need to have so many errors. The difference between this system being good and being unusable is how good we can handle errors. Right now we are using why do you keep saying Twitch chat move, but then nothing's going on? This is messing with me. Anyways. I need to stop flickering and taking my attention. Okay. So you have error. Error is... Okay, so that's this error. And then I'm using mite errors for... I'm using this crate called mite. This is it? Yeah. So it's this library for fancily emitting error messages, basically. And it has a ton of macro stuff for structures, and just like you fill out the structure and it automatically formats it for you and all of that stuff. The problem is their documentation is just I can't understand it. Just straight up, I don't understand how to use this crate. And so that's basically just, it's kneecapping my ability to write errors and whatnot. So what I think I'm going to do, also it doesn't, the way it handles source code is really weird, and just like, yeah, I don't know how to deal with it. So what we're going to do is there's this great project that's been around for a little bit that does have error reporting working the way I want it to, and it's this thing called BrainScript. Yeah, look, I recognize that. Anyways, if we go to compiler and then emitter, this console emitter yeah, this is basically exactly how I want error emitting to work, with like a little builder function, and then we just emit a diagnostic in place. This is how I want error checking to work, or emitting errors to work, like to the command line. Now, how do I want to handle errors in the actual runtime? I'm not sure yet. I'll probably just keep using this error because it's good. I can just write an enum of every single different error state that I care about. But the problem with the way that this error is currently working with MIDI is that I can't deal with it. So I'm just going to copy over the not emitter, but I'm gonna add in a, call it formatters. Create a new error module. And I think I'm just gonna rip MIDI out and use my own formatter, because MIDI might be good. It was recommended to me by a chatter, and that's why I tried it out and it worked. But I can't use it. Then again, I've never really, I always prefer writing my own things over using docs. This is using, I am going to be using a formatting library, but yeah, we're not going to use something that exists for the actual formatting of the error. Do I need to do source manager? I probably need to bring over the source manager as well for this, because that was a very important part of the BrainScript system. So we're also going to need to not only bring over the emitter, but also bring over currency source. Yeah, this whole source manager here. Because I liked exactly how this worked. Guys, I swear this project isn't just turning into brand script. Okay, I figured out why Twitch chat is working. It's just showing me the welcome to the chat room every 15 minutes or so. Very functional platform. Mod sources. We'll just call it source. Oh, nice! It renamed the file too. It's really nice. You can't find source RS or source mod RS. It's right here. And then we don't need anyhow. We're not going to use anyhow at all. We're going to use... Where is URI in BrainCore IR? URI. Right. We have expressions. And we need to know. We need to know when evaluating this. We always need to know where the expression is from. I want to keep this as... Do I have to do the expression kind wrapper thing? Yeah, I probably do. That means refactoring everything, but that's what you have to do when you refactor your error system, is it touches every single part of the program. Looks like you're streaming. Would you like help with that? No! I will suck at streaming on my own, without AI's help. Engagement? What's that? There will be no engagement. There will be no retention. There will only be yelling at code. Nothing more. Yeah, so I need to grab this URI struct from somewhere. What do I've been trying to avoid arc references. Wait a second. I know how to handle this. We add the solution to every problem in programming. We're just going to add another hash map. So instead of URI being something that's part of the IR, instead we're going to have source IDs that are just going to be a U size. So sources are just going to be a vec. What do you mean my project lacks documentation? Just watch through the hours of streams for the... Exactly. And if I wasn't streaming that day, it just means it wasn't meant to be documented. But it's fine. This particular project, I actually don't have this project open source because, I don't know, I want to think about this project differently. This project's for me. This project is just what I want to do. It doesn't need to amount to anything. I'm just making it. And then I'm the only one that I ever plan on using it. And counterintuitively, that might make it actually successful in the future. But yeah, we'll see. We'll see. So we're gonna have sources, and then we're gonna have URI to source, which is gonna be a hash map from URI to usize. Or here's what we'll do: hub struct source ID usize, and I also want to copy over from the VM, no, from allocation. Ooh, I just had a realization. I was thinking, oh, how am I going to, how am I going to keep track of my source code? Like, how do I make sure that, how do I make sure it gets deallocated when it's no longer referenced? How do I do all these things? And then I realized I have a virtual machine with a garbage collector right here. I could technically just have source code be a buffer inside of the virtual machine. Technically. Do I want to do it that way, though? Watch the VOD. Yes. I mean, you can surely try. If you are able to reverse engineer what I'm doing from the stream, I will be impressed. I mean, I am figuring out, most of what I'm doing is figuring out like the hard design decisions, and then the implementation is intentionally as simple as I can make it. Okay, here. Yeah, do I just want to do buffer IDs for source code? Do I just want to do buffer IDs for source code? So one of the reasons why I'm thinking about sources so much is because I want to be able to run this virtual machine in a continuous loop, to be able to provide like a language server protocol, like an LSP server for the language. That way, like, you can actually have like error checking in an editor. Either VS Code or Vim both use LSPs. Which means I need to be able to store a local representation of the entire file that can be edited through Delta updates over from messages that I get from the server. that the server that I'm providing is getting from editors, basically. Because an editor will say the user edited this range of text and replaced it with this range of text, instead of sending the entire file over every single time, and then you have to like perform the edit on your end, and after you perform the edit on your end, you have to like revalidate the entire file, and sometimes you only need to validate half of it because like, oh, it was only these things in that range that were like edited and whatnot. This is like, there's optimizations you can do that I won't be doing. Yeah, I do. Okay, yeah. To try to keep everything, to make it simpler, to make it more complicated, we're gonna have the source manager just be the virtual machine. And that's how we'll do it. Our source code is just going to be an object inside of the virtual machine. I just realized Jai does the exact same thing. They have a source code type. Guys, I'm not Jonathan Blow from Wish, I swear. Okay. Jonathan Blow from Temu.com. We need to reference source code for good error messages, as well as LSP operations, allegedly. And potentially some compile time code might want to... I don't know if I want to... That's just straight up not a reason. Like, if we need to be reading the source code directly for anything but error messages and LSP operations, then that's a failure of the information that I'm giving to the user, and we just need to have a code concept, like a native concept of the VM or parser that makes it so that they don't need to manually parse the source file themselves, just straight up. So our virtual machine code should never need to reference the source code. But it would be able to if it wanted to, since we are making it a native object. What else for good LSP operations? We need to be to keep an in-memory reference to source code files. In-memory representation to source code files. Keep memory management simple. Keep memory management simple. We will be representing. Ah, dang. Now I'm thinking like, oh, all of my intermediate representation, all of this. Instead of just being native types, all of this should be like objects in the virtual machine. That way, we could do Lisp. We could do Lisp style macros that just operate on the AST if they want to. Even though I think AST, actually no, not AST macros, instruction macros. Even though this is kind of the AST, like it needs to be the AST, but some code we might want to write virtual machine code that analyzes this, also for writing emitter code or standard library code, and it needs to like choose like, okay, do I emit language? Do I emit the target language, or do I just for emitting to the target language we need to just directly read this code, read these objects instead of their values. So making these objects would make it, making these virtual machine objects would make it so the virtual machine could write emitter code. But that's a lot of work that I don't want to have to deal with right now. It might be like really simple in the future, but right now that would be a lot of work. So we bootstrap it. To keep memory management simple, we will be representing, we will be storing source code text as buffers, as objects that contain and we don't need types yet because it's entirely whatchamacallit. Entirely dynamically typed at the moment, so I don't need to worry about actually defining types for this yet. We'll do that later after we've figured out our error checking system, basically. So for code, we need basically the backing file. Yeah. So we have the file path, which will be a string, virtual machine string, VM string, and then we'll have the actual text, which will also be a string. I think that's all we need to store for the moment. So if we need to add in more metadata later, then this is where we will do that. I don't know if the string needs to be optional or not yet. Yeah, I think that's it. Okay. I think we're going to put this in the standard library. Where did I put it? Ah, here it is. Public code is an object. Oh, wait a second. I could do string is just, oh, these are for the types, not for an instance of the types. This is going to be an object ID. So here's our definition for VM string. Let's do store object view hub struct. Call it VM code to keep with our naming convention. And then public file path VM string hub text VM string, just like so. This will be fairly easy to work with, all things considered. Yep, so there's our code object. Now, we need a central, do we? The code here, which will have an object ID for the code. Okay. We'll also need, hello. Also need VM, this is our code. So how do we want, so every single value, right now what we're doing is we're working on basically a dynamically typed language that runs at compile time to emit code. So the hello world basically looks like this. Just import some C stuff, define a function, and then manually call like the object construction stuff and a linker. Basically, it's a macro system, build system, and coding language all in one is kind of the idea. But easier to work with because it's, you know, all in one. You don't have to switch between contexts. Yeah, okay, back to what I was doing. Right now, what we're trying to figure out how to do is I'm redoing the error system because right now it's bad enough that I'm just not using it and just crashing the program whenever there is an error, which is fine because since it's a language that runs at compile time, compiler errors are just running the thing and it fails and you get an error. But ideally we have a way to like print good errors, so that's what we're working on here. So just find the way that we're storing source code, that way not everything has to have a reference to the source code. And I'm trying to just figure out how will my intermediate representation, if I go here to IR, how are these going to keep references to where they're referenced from, basically? In existing compilers, the general terminology is it's called a span, right? Yeah, like a code span. So maybe we just call this VM span, like that. Then VM span needs a reference to pub code. Then a VM code reference there, and then we also need the range. This is another VM object. So I guess, yeah, I'm going all in on we are going all in on all the source code stuff being handled in the virtual machine. So VM range pub start is I64 and pub start and stop begin end. Is it begin end? I think that's what it is in C. What is it for Rust standard op range? See this start end. Okay, so it's start and end. Actually, what can I do? U64? Did I do unsigned integers? I don't think I did. At least not on the VM side. So this is just I64 and I64. Oh, this is that one song that just has the really long end, I think. There we go, yeah. Okay. So we have the code range span. So now we have a VM span. Yeah. Okay. Do I still have a block ID? I don't have the concept of blocks anymore. Do I? Does this have any references anywhere? GR. Block ID equals usize. Okay. We don't use it. I don't think I have phi nodes either. Okay, wasn't using any of those types at all. Okay, now for our expressions to work, we need to make this expression kind, and then we need to make expression public struct expression of span equals a VM span and pub kind equal ex per kind. Now what's really nice about the way that about having these spans as virtual machine objects is they have direct references to the source code, they have a ton of data in there, but in terms of space that they're taking up in this actual expression struct, they're a single U size, so there's 8 bytes. Now, is it efficient on the pointer side? No. Memory, not cache efficient at all, but this thing doesn't need to be super efficient. It probably needs to be more memory efficient than it is space efficient. So we'll import span there. Dang it, I need to... I need spans for all of these things now, too. I also need to give intrinsic functions names. That way, when we're debugging, it isn't just like, oh, this intrinsic function failed. So all of these need to... Ident doesn't need to have a span. I don't think call needs to have a span either. Because the intrinsic... Constants do need a span. Constant reference kind of ident doesn't, because the ident itself could have a span. No, idents don't have spans. Dang it. Okay, yeah. Yeah. I guess we can just put the same span on the constant. So we're gonna say ID span. No. This is the same span for both of them. Go, and then for here, I just have to do the same exact thing, and I'm calling this call span in the argument instead of just spans as a little bit more understandable. And I just, what the hell is going on? Okay, so I want human streamers to be gone. And then we need to implement GC referencer for expression. And basically what we need to do is function call this for reference kind object for self span D. There it is. Now VM span. Now will you do? Let me do. Is it public? Has to be public. Won't be used if the trait is in scope. Well, then I need to import that store object. Yes. Now we need to do self dot find dot block strong refs f. It's like that. And then that implements, that fixes that GC referencer down there and all that. Now we have to fix the calls to where all of these are referenced. We actually have spans throughout everything. Keep this error here for a while because that's the eventual error that we want to fix. Now we need to go to executor and do x for behind Ezra. Like this is unreachable. Clearly there are cases where value might not be bool. Maybe... I don't know, I'll have to... I'm gonna try to trigger that, to be honest. Surprising lack of errors. Let's see how much this broke the parser. Named source. Oh, right, because I'm not using Mite anymore. Means I need to actually do all the crap here to... Yeah. I don't think we're ever gonna do... We're gonna rename this load code file. We're gonna forget about load string for now because I don't want to deal with it. Tokens. So graph tokens equals got to copy over tokens. That's important. Yep. Don't want to do this anymore. Yeah, well, tokenizing is just much easier to keep. Just keep it as a string for there? Actually, no. No, wait. For the LSP, we're gonna need a way to retokenize things that aren't. Actually, in that case, I'll just do VM string, and that will be able to return a string reference. So we're good. But we'll just keep this as it is for now because it makes it easy. And load error. This is the first error. How do I want to represent this? So in here, we need to do basically just code, right? For the moment. Here we'll need the actual code. Load error kind. File load failed. Not gonna have diagnostic anymore. I think we're gonna have error reporting and actual error handling be different. These will be diagnostics anymore. These unexpected errors are kind of just bad, if I'm being honest. We'll need to keep them as is. We don't the way these are right now, but let's bring these down. I think, yeah, Lexer error is just unexpected character. This is fine. This works good. Lexer error from unexpected character. Failed to load file. char parse error. Expected token doesn't implement. This is happy with actually, I don't want the code here. Load error Lexer, load error parser. Load, because error is implied by the name of this enum. Let's just remove error from that. Unexpected character, parse. Yeah, we'll just do say parse error. The difference between expected token and unexpected token? Nothing. We're gonna say unexpected token. We can just do end of file. Assigned to the result of a function. Would be a grammar error? I feel like this is the runtime thing. And assigned to the result of a function. It does make these results basically useless. I want to do unexpected token. Yeah, unexpected token. How do I say the token kind that was expected? We have public. Just pass in the current position of the unexpected token. Token kind? I do have expected token kind. This is perfect. And we can put in a vector of expected token kinds. I think instead of error here, I like anyhow, but actually could probably do anyhow error for that. Transparent, unexpected token. Yeah. Just say dot. Then I don't know how I'm going to handle grammar error. This is basically useless. Am I going to implement a trait? I am going to implement a trait, yes. So we're going to say, okay, which file am I in right now? Mod.rs? It's probably not where parser error should go. Parser error should go in the parser area. That's fine. Eventually we can make that better. I think expected token error is... Yeah, we would just have that gone. Let's move all of this into our parser. Errors at the very bottom. Then mod rs can import them like that. I delete something? There we go. Literal kind, shouldn't this be in Lexer? Yeah, it is in Lexer. Why am I importing it from VM? Maybe it's re-exported? I finish writing up the parser before I fix the stuff that calls the parser. I need to put spans on the tokens. Might have to put spans on the tokens. We break my Lexer too. We break those, we break those. Oh, we already do have spans. Thank you. Thank you, past me. then I do not want to compare spans. Only token kind. Tokens do fully have spans. Amazing. While we're at it, calling this characters, I'm gonna call this flexor context. Let's get a VM reference in here. We're gonna say tokenize code. This is going to be a VM code reference. And we're also gonna have a VM moot virtual machine. Okay, we'll just throw a VM code reference right there. And we'll also say VM, which is a it is the virtual machine. Now, we do have a dilemma, which is that the source string itself that we're referencing, we know that the virtual machine is never going to mutate it, right? During the course of the operations, but Rust doesn't. I was going to be like, how are you going to have a reference to a string here? This is going to make the Lexer significantly slower. There we go. Now we're not holding an immutable reference to the source string. Yippee! Okay. So now we do peak. We need to do get text string. Lifetime be returning the string, and this is from self. No, just self. I'm actually like really unsure how the lifetime system is going to handle this. So if I do self VM store buffers self text, and then this gives me a vector. Then I say string from UTF-8. I'm going to say unchecked because I know it is fine. Maybe this will work fine. I don't know. Okay. I'm honestly very unsure how it's handling all of that, but okay. So now you get a token. We need to. This actually requires moot self. No, because we're not changing self. This would be self VM store objects register VM span. Second. Restart the editor, that way my LSP is actually working. Do from store structured just to make sure that it's right. Okay, here. Expected mutable store found store. See how much work this is. I have to grab the type. Yeah, so we're creating an object type here, which should be a span type, but we're not doing span. Okay. Here, into the map, and we'll be right back. Let's see, where is there? Thank you, I will need the good luck. But yeah, we are making a language that writes another language, basically. Metaprogramming language. Yeah. This macro right here is creating an object inside of the virtual machine of this type, which is why, yeah, it's complicated. But yeah, I just had to open the window because it's getting 82 degrees in here right now. Okay. So begin span, what are my objects? Code and range. So we need to add the code object and a range object, which means I have to create a range object. I don't have to manually do this every single time, so I think here's what we're gonna do. We're gonna go to span here, and we're gonna implement VM span of new for the span we need this range. Let's just do a standard ops range here of view size. And then code will also just be VM code. Then VM range, we're also going to implement VM range. Wait. Start. And both of these need a readable span reference or store function or reference. And I need to fix the macro so I can do non-order dependent checking of members on creation. But let's see, let object equal VM object. Like that. Get away with this compiler for. So I just like writing scripting languages in general. That's my main justification. But what I eventually want to do with it is write some small, maybe large game engines. We'll see. I thought I did a version of this that didn't require a path. Yeah, right there. Single underscore. If I do store, yeah, okay, that's how I do it. Object with no type. I need to be doing that more often. Eventually, to do use a range type here. That way, like, we can actually check that it is, in fact, a range type. We have start. Progress is going well. Before I started working today, the program actually ran. That's not what I meant to do. I want to clear the screen. But this is what the hello world looks like. It's basically a very thin wraparound C code at the moment, but the scripting language essentially acts as a really good macro system and also a build system, so you don't have to deal with like the two main, and also a generic system. So you don't have to deal with like the three main deficiencies of when you're working with C. And I might also make this eventually output like JavaScript or whatever if I want to not have to write JavaScript. So I just write entire language so I don't have to do that. Store structure. There we go. And now let's do the exact same thing for VM span. So code will just be code.getID. OBJ. Be there. And then range will be VM range new range. Actually, implement from standard ops range. Size for VM range. I should probably do this for both usize and isize. Or I64 and integer 64. Oh. That's not what I wanted to do. Oh, wait. That's what I wanted to do. Do have to do create here. Oh, I need a dang it! I need a store reference, so it just doesn't work. Gonna take you weeks or months? Definitely months. Was using WASM to avoid JavaScript not an option? Not really. You can't. If you actually want to interact with the DOM, you're using JavaScript. And it's more so of a cool idea of like, I can have this one like macro intermediate language that just works for emitting anything basically. Helps me think about the structure of this isn't a language, this is just a language that emits other languages. Just completely shifts the way that I think about building it. To where I might actually complete it and use it for things. There we go. Now I actually will be... I'll be able to survive using these now, since I can just say vmspan create. Instead of doing all this BS, we just do vmspan create. Then we can do start self codes like that, self code like that, and it already has an expect in there. Boom. Instead of learning a language, you're making your own? Pretty much, but to make languages, you basically have to know how all languages work to a certain extent, or at least you don't know every single language, but you know how languages are made. So I already know all the languages that I want this language to implement. I just don't like them. So more so, I'm writing a language to avoid having to write languages. Wait, is it already registered? Yeah, it is already registered. It would be. Cannot borrow VM store is mutable if it's behind a immutable reference. Self is a... Okay. So that's how the borrow checker handles that. Fair enough. No. I want to avoid write. I don't want to directly write C or JavaScript. So I'm writing a language that will write them for me. just realized instead of having text be FID, we do need it's just VVM string. Why is this always failing? Unreachable expression. From what? Oh, it's from the to-do. Let's see about get text string, restore buffers, self-text. This is now incorrect. To get this, we need to do VM or self text as string self VM store reference. There we go. Am I done? Okay, mismatched types. Oh, this is in parser, not in I want Lexer. Is the Lexer failing at all? Nope. No errors in Lexer. Get rid of all the warnings in there. Okay, no more problems. Then this is having mite errors, so let's just remove mite from the next. We're not going to be using it anymore. We're going to be using our own emitter system. It uses a different formatting library. Now we look at the parser. With the standard library. What the? Bring me back. There we go. We just return VM standard library and we're good. Fixes all that. Then we need a way to actually... Where is this being used? For errors? Only for errors, okay. It needs to be used for a lot more than just errors. Let's get our actual error emitter working. Referencing the other time I've done this in my other language. you look at the emitter. So instead of emitters, we're going to call these reporters. Annotate snippets and AM stream. Console reporter. Render, annotate snippets renderer. Okay. Other thing that we need is we want a full virtual machine reference or just a store reference? I think just a store reference. I just tried using Vim key bindings to get over to my web browser. What errors do diagnostics have? Because I don't want to use anyhow error, which means we're gonna have to come up with our own error our own set of anyhow errors for it. And generally this shouldn't ever fail, right? At least I don't think it should ever fail. We don't have a source manager at all, but that's fine. Because the place we actually get the text from is the store. And when we emit, we emit the message in the store. Agnostic builder. What? Guess I don't need to. Could straight up return these things in error messages if I wanted to. Love so things don't have lifetime references anymore. So much. Makes them so much easier to work with. these easier to work with if they had a store reference. That's fine. All of that works fine. All of that works fine. This does not have a lifetime anymore. I'm just gonna have this as a placeholder. That is so many unwraps. It's fine, because this code will never go wrong, right? Can I just do store since it's a reference? Probably. This is already a mutable store. Mutable store reference. This doesn't need to be mutable. It wasn't. Hit range, unwrap, cut. Oh, A is for annotation, not like AB. I'm not reading my own code here. You can say let code equals that. Source text equals just like that. wait, that requires mutable store. This does require a mutable store, because it does have allocations with the VM. Know for sure the diagnostic reporter emit shouldn't need to allocate new things. No, the emitter doesn't need a store at all. Message. This is just us pointing where the message goes. Oh, wait a second. That's right. This takes in just the regular range. I can do this. Oh, joy, that's actually... Go? Now using VM stuff. Just doing fold. Oh wait, these are the starts. I was going crazy there. Wow. Rootable borrow used later here. Current snippet auction decrease none. So what of these gets referenced later? Rootable borrow. This is the thing that is complaining about. Cursor, source text. Cursor, line of. Snippet require. Oh, it does. Do I define snippet? I do define snippet. Okay. Instead of source text here, just do code. Pick the problem down the road to here. Then let's copy source text here. So this is snippet. Source code get text. Go. So that should fix the borrow checker errors. Thing about source text. Self has no, okay, yeah, it has no things. Okay. Where's the borrow happen? Tell me, where does the borrow happen? Here's where it happens. Cool. This file is theoretically now fully valid and will theoretically work. Fancy system for printing good errors. This will be good. Okay. now whenever I have a diagnostic, I can just use the builder to create it. Have full control over the format and everything. And unlike that other library, I have full multi-file support. So one error can reference multiple files. Which is huge when you say have libraries or more than one code file. So now what is this? The library? See the standard library and the standard library? Not my errors themselves. Now that I have a way to emit errors, I need to figure out when I'm emitting them. So Parser currently has the... But no, Parser is an instant failure sort of deal. But let's look at the error handling for it. Grammar error at VM spam. We want something better than grammar error. But but expected token is basically the closest we'll get. Yeah, we straight up don't use it. Okay, I'm deleting grammar error because I hate it. We're gonna say, we're just gonna use unexpected token for everything, even though it kind of sucks. I just have the token here. Tokens implement copy, right? Yeah. Error at oh, that's what I did. Okay. We can say new. Then this is going to be unexpected token. And then this is going to be a level error. Error at takes a VM span, so we can say self unexpected span. And then we could say expected, then self-expected dot iterate. Then we need to map these to strings. Actually, you know what? This isn't the only place I might do this. Indeed. Though it might be simpler than expected. Why is this all broken? Oh, right. Turbofish syntax. There we go. Be right. Going with comma. There we go. And this will be... That's how easy it is to make an error with that system there. Which, like, yeah, you can do with the derive macro stuff, but I wasn't able to, like... There's a lot of memory management stuff that the derive macro, like, Mite stuff did for me that I just didn't like at all. So doing it manually, we got to do all of it manually. We don't have to worry about it. So now we have diagnostic. Unexpected token. We should probably do it for parse error as well. Do like the idea of, instead of just, you know, immediately emitting all errors, instead we have the chance to error check, I guess. I do like the structure that Mite was using a little bit. Not entirely sold on it. We'll try it out, see if it works. We can always backtrack. We'll do the exact same thing here again. With, but this time we will say design to result the function. Does that mean errors are GC objects? Technically they should be, but I think we'll always handle errors. We'll never emit an error, have garbage collection happen, hopefully. We should never emit an error and then have garbage collection happen. It would be very unfortunate if we did. Need assign to result a function, error at self at, then oh, right. This is an enum. And this is the one that I needed to do the diagnostic for. Specifically only this one. Then for the unexpected token, we'll just say UT. Basically do pass through there. I don't like the indentation on this, but it's fine. Great, let's implement diagnostic for our Lexer errors. Yeah, I just have to do VM span here, unfortunately. Say error at self span, and we'll just say span. bet. Yeah. Implement display. You can implement display for where T is a diagnostic. You don't need to tie this to emitter. Do we? Actually, different renderers. We do need to tie this to an emitter. I'm just getting rid of the concept of diagnostic reporters. I'm saving this code for later, just in case I want to use it, but we're just going to make it so diagnostics have to renderer string diagnostic render error. And then render is anything that implements a reference to annotate snippets renderer. And now, here, I don't have to do any of this BS. I can just do renderer plane, then you can do self.emit or render. The store. Dang it. That's fine. We can still. In any case, that's a lot cleaner, a lot less dependencies. go. Because it can just decide when to emit error. Make sure Lexer is doing fine. Then these get an overhaul. actually have to pass anything extra into parser for it to work. Need this to return. What's this used for again? For errors, okay. And that's it. Hello. How goes it? Let's see. It is a little bit complicated, yes. We'll see how it feels once it actually is fully working. For reference, this is what the code currently looks like. Right now, all it's capable of is just building a C Hello World program. But if you look here, you'll notice that it's all one language, and we create an object, we link an executable, so the build system is actually part of the language itself, and also like macros and generic systems are going to be part of it as well, because what we're doing is creating a dynamically typed language that runs at compile time to output other code. So yeah, we'll see how it turns out. Right now I'm just in the middle of elaborate on which part. Have a clean way to create an build system being part of a language. Okay. Yeah, so the idea is that I'm not writing like a compiled language, but the result of the language is compiled things. So it's a dynamically typed language with utilities to compile stuff. So the idea is that if I define a function in this language, it runs as much of that function at compile time as possible, and where there are like placeholder variables where it doesn't know the values of, instead of trying to compute those, it will just emit code and then compile that. And then you're left over with whatever it wasn't able to compute at only compile time. And it can like run functions on types and all of that sort of stuff. So when I say that the build system is part of the language, I have never heard of immediately consumed runtime level language. Let me look up what this means so I can tell you if it's true. They refer to dynamically interpreted environments like a JavaScript or Python, where the runtime engine parses, compiles, begins executing source code line by line immediately. No. So it's not doing this. It has a separate, for one, it has a separate parser stage that turns stuff into a bunch of ASTs. Then it has a virtual machine that it runs, and that virtual machine can choose to either just basically constant fold stuff or emit like a string of C++ code. And then it also has functions here. So when I do emitter clang, this is just getting a reference to a library for interacting with C, basically. And then I can grab reference to the standard library, and here we're calling printf inside of just a generic function. This C object thing is... Right now I have it so curly braces are actually a function call, so this looks like we're instantiating an object, and that's intentional, but... Oh, wait. Rip. You're right. This library... Let me see if I can get that. There we go. But yeah, so we grab a reference to that, basically to C. We grab a reference to the C language, grab some libraries from it, call printf, or this is basically just our hello world thing. I think the closest thing academically is a multi-stage programming language. I think this is what we're... yeah. Program that divides compilation into a series of explicit immediate classes. Maybe not totally like that. But the idea is that this code is run at compile time. Some of the code results in C being written inside of C object. Anything inside of here, these functions, it tries to... basically, it tries to run the inside of... yeah, when we call a function, it tries to run it, or it tries to evaluate it into code. For anything inside a C object, it just straight, like, always generates a C function for those. Similar to LLVM in terms of readability. I hope it's more readable than LLVM bytecode. But yeah, so I'm just able to create objects by defining objects, link all those together into an executable just like that. And the idea is that you're not using multiple languages for everything, it's just one language for everything. This is true. Yeah. Hopefully in the end it looks a little... somewhere in between TypeScript and Rust is where I'm leaning more towards Rust, but somewhere in between TypeScript and Rust without lifetimes. There will be Rust style like pattern matching on some things, but yeah. Okay, what am I gonna do here? I know... do I just create a new span? Yeah. Get the code reference. We grab the end of the range. Then our store here, or not store. Our span, that's what we're going. VM span, create. Then this is just going to be code and and like that, the VM store there. That's all happy, and then do the same thing here. 0 and 0. Fortunately, this means we have to make this a moot self thing. Like that. I do like Rust. Wait a second. Oh, dang it. No way to get code for this one. So if we can't get the current token or the last token, honestly, this should never run, so I'm just gonna say, just gonna panic here. I do like Rust, but I don't want to build what I'm building in Rust because it would get in my way too much. Because I'm planning to build a game engine with this, and with the game engine, I have the idea that every single place where the program touches another program, I want to be the one writing the code for that. So it's kind of like I'm fine with using libraries internally for the engine, but then all the interfaces where it touches other things like graphics, audio, VR stuff, because VR dev, all of those places I want to be the one using the C bindings. That way if there are any bugs, it's on me to fix it, because that's, yeah. So the problem is Rust doesn't help at all. It actively gets in your way if you're trying to use a C API. And like there are Rust abstractions for most of the C libraries that I'd be using, but I want to use the C interface. So I'm like, okay, that like brought me down the path of like, okay, if I'm not using Rust, and the reason I know that I don't want to use Rust is because I got as far as a Vulkan triangle in Rust with like C bindgen generated bindings from like that. I'm like, I don't want to go any further with this. Rust is just getting in my way like way too much here. I want to use C, but with a much better macro and generic system and build system. So that's basically what this language is. It's a wrapper for C that makes it work the way that I want it to, while still having like complete. It works completely with Rust, or not Rust. It works completely with, yeah, existing C libraries is what I was going for there. Actually, wait a second. I'm realizing I don't have to do all that. Let's see else. None, and this will work as expected. So this will be like Unity script. It serves as a wrapper that abstracts some of the C# stuff beginners don't understand, as well as the game did be more accessible. So it's not a wrapper over C# at all. It's a wrapper over just C, with no sharp. Natural C. Native C. And the goal with this project is just, I want to build game engine for fun, specifically. If I was trying to be practical about building the game engine, I would go about it. I'd probably just use Rust, to be honest. Just use straight Rust. Because it would be the most practical option for everything I want to do, but building a game engine for fun, I'm like, okay, I'm gonna build my perfect feeling language. Nice. Yeah, engine programming, the further you get into engine programming, the better programmer you get. Like, it can take you to code. Game programming is the most general programming you'll do anywhere. You have to learn everything. The more you know about coding, the better, like, technically things will work. Technically, though, you don't need to be a good programmer to be a good game dev. Making a fun game is an entirely different skill set for making a good game. You can have the perfect code and just a shit game. And you can have terrible code and a great game. Though, hopefully you're somewhere in the middle. Or just have a great game and great code. Okay, so now we have to fix the errors. So expected token error. This should actually be an unexpected token error, because I deleted the expected token error because it was stupid. Yeah, that's probably a foot gun that a lot of people are going through right now. I'm lucky in that I learned to code before AI was a thing, so when it was like coming out, I could tell all the code it wrote was crap, and I didn't want to deal with it. But yeah, the hard part of coding isn't the languages. It's definitely the first barrier people encounter. But the hardest part is just logical thinking and problem solving, which AI hasn't figured out yet, because that's literally not how the code works. It can predict the structure of language describing a logical thought process, and with a lot more compute, basically it can do logic through grammatical structure of logic. If your grammar is correct, your logic is correct, right? But yeah. Also got work experience before employers got a bunch of weird ideas about the readiness of AI. This is true. All my work experience, I have not ever had a regular job, ever. So, yeah. Never have I got a job from submitting a portfolio, so I can't give you any advice on doing that. I've only ever gotten jobs from people seeing my stuff on social media or through people I know, which, to be honest, if you can do it that way, do it that way. They will actually want to hire you. And the interview will basically just be them, like, doing a personality check to make sure you're not insane in the wrong ways. to study CS because I used to tinker with games. Mega Man 2 in hex editors and 8-grit. In hex editors? Nice. You need a vector for the expected. So this is in the case of there being multiple correct options. I'm not using it a ton right now, but most actual like real world parsers will give you a list of the different expected tokens it could have expected at any one point. Like, honestly, it's not that helpful because a lot of times you want to know next expected grammar concept, not next expected tokens. Then you have to guess at which like grammar concept it was expecting. But this is the best I can do right now, is a half-assed implementation of. This is the one thing I was expecting. Expected. Okay, what is my expected? Okay, so it's expected token, which means I can just straight pass that through. Unexpected. Do I have a way to say token kind, end of line? Or it's like nothing? I think I need this to be optional. Unwrap or no. That will work. Cannot move out of unexpected as a ref. Realizing that coding isn't always going to be fun in games, and that boring and frustrating debugging sessions that might steal 8 hours of sleep aren't what see on social media. That stuff is what actually makes crack good programmers. This is true. Real story from the job I work at currently. I spent 2 weeks trying to solve a problem, and the solution ended up being 1 or 2 lines of code. However, those 1 or 2 lines of code were a patch to Unreal Engine that regularly save every single user in our game like 3.5 minutes of sitting in a void inside of your headset every single time they boot up the game. So those 2 weeks were very worth it. But like if you measured it by lines of code versus the time I spent trying to figure out where to put those lines of code, yeah, you have to look at the whole, like, the big picture. Spin on option token. True, the span would be No, we're not doing this way. Yeah. And like even with like streaming like this, I generally tend to like I don't really stream for people to watch. I stream as like a basically as like a body doubling technique. Like I stay focused while people are watching me. I can't, we're not gonna scroll Twitter on stream. I mean, we could scroll Twitter on stream. Like let's see what's going on. Green Man. But yeah, no, I'm not gonna open Twitter up on stream. It's mostly as like a way to keep myself focused. But even then, like I'm only gonna stream like when I actually have the motivation to. So, but most of coding is literally just, you know, debugging. 8 hours of 8 hours of pain and suffering to, but then when it finally does, but you're trying to fix it, like the high is like 8 hours of trying to get something to work, and that hits. Okay, so how do I want to do when self-span? So let me... This is what I'll do. I'll create a, when we start parsing, you know what I can do? When we start parsing, I'm going to allocate, where is this? This is a parse context. We're gonna have an end of file span, VM span. And the end of file span is VM span. We do tokens last? I think we just do tokens last. Ooh, what do we do if... Here's what we'll do. This is the semi-annoying part about Rust, is they make you account for every single possibility. It's the correct thing to do, but... And the file span... Here, if there are no tokens... Yep, I can't create a span if there are no tokens because I don't have any, like, I don't have VM code equal VM code create. Did I do a creation function for VM code? Where do... This is a standard library. Yeah, I didn't make any helper. Did not make any helper functions for this. I think in here have I never instantiated a VM code object yet? I don't think I have. Path is going to be equal to VM string from string do need standard library stuff, so let's say this should only be created when we have a VM, so it should be fine to do. Require virtual machine for this, so from string VM standard library. VM store file path from string. Does this also do as ref string? It does also do as ref string. And then here we do text file path text VM code store structured root VM store. There we go. This little wrapper to be able to build this thing. And then we can create from no code zero zero and then VM root store. And that's our end of file span in the case. Here we go. Okay, and then we can do EOF span. Nice. Then here you can do self next span. Just do VM span. So then this should be good. Expected token found. Okay, yeah. Next if feel like next if I need to do peak or I also need an end of file token, don't I? So so this will be token with a span of self EOF span and kind token kind EOF end of function. So I can do peak or EOF. See, expect any, this is where it uses the vector. So what it does is if we don't find any of the expected options, we go through and there we go. Luckily, there's not a lot of places in the parser where I manually create an error. Okay, self peak was true. This means unexpected gets to be self next. Unwrap. Okay, and here we can just do... I need to go through and actually implement adding spans to every single expression type we create. Will be our span of our last of. Okay. We need to create a span. This one doesn't really need a span, but why is it so hard to figure out what spans should be? Oh wait, I have return type just hard set to none. I straight up don't figure it out. Okay. To do. Return type? Maybe, maybe not. We don't know. Oh wait, no, this is parse script. We're good. Okay. Span equals return. So the span of this expression would literally be the entire file. We're just gonna do self EOF span. It's not worth it. When I parse the function, I think there'd be no merge function, but I am going to add one back because I do like, what is this, at the end of the function, or file? Scroll for 800 lines. And here, what we'll do is public function merge. We'll take in self and other, which is also unexpected token, or self, and return of type self. So I'm gonna say create a new self. Unexpected equals self unexpected. And expected There we go. So that merges the two unexpecteds together. That way, if we're expecting multiple things, it's an easy way to like merge those errors. So we're expecting more things. So here we were expecting an expression. Dang it, I don't have a way to say grammar concepts. Some T next. Do I have expected token any? I don't, but I need to add it. There we go, finally. We get into refactoring these. Okay. Once found for struct expression, but what about expression kind? There we go. Func ID self parse function. Function ID is a function ID. Parse function. But I need a span. I think I need a combine for span. There it is. That's true for a lot of things. Usually if someone says they can't do something, usually it's just that they... something along the way made it not worth it for them. I guess. Okay, so now we have our two ranges. So now let's do VM span create from we're gonna assert that should work, right? Won't do it for result. It can't be applied to. I need to add that to the macro, so I don't have to manually object ID it. I want to compare those by reference. By address. Compare by address, I think, is the correct term for that. So many unwraps. Okay, and then we want to do a min b or wait a second. Must combine. Okay, now we're just going to do this manually. A start min with B start, and then a end max B end. And this just gets like, if you have a span here, you'll end up with span here. And with that, I can do amazing things like parse function to get the span of the entire function. We can do then here, when we actually create the function, what's wrong with it? Tuple function ID. Tuple. Here we go. Do items need spans? Items probably need spans. I could have done t.span for this. That would have been fine. And that would have been the first character of the thing, but well, now I have the ability to do the entire span of the thing. Okay, so here we have the I think I need to do span of this equation is t dot span merge, and I think with this one too, actually, span dot merge with t dot span. Span merge self span self VM store. Okay. Then here, where did I put the need for the span at the end? Name ident. Where do we get name ident? Name. Expect ident. Here we need wait. I should just be able to do this, right? There we go. Oh, oh, accident. That's actually really... So for my virtual machine to work correctly, I just have hidden function calls when you do curly braces to begin and end scopes. But yeah, I just did this without thinking about it, but this span would be the open brace, so I'd say that this call happens within that open brace is essentially what I'm saying there. That's I find that cool. Close scope equals... Bit of arcane lore for you, but loops and rust can have return values. Infinite loops and rust can have return values. Which is what I just did there. get the closing token span. Yeah, you just put a return value after break, and yeah, it returns the value. Thing that I have never used before, found out while I was reading the Rust parser, and I'm like, what the fuck? Why can breaks have a return value? And it turns out, yeah, breaks can have a return value. You can also label scopes and break out of multiple loops at the same time. Lots of weird esoteric things that nobody ever uses, ever. Bro, I could go over every single member of this match statement and could say all of the things that this could have expected. Don't really want to, but it's what we're gonna do. So what are all the things this thing could expect? This could expect if, this could expect let, this could expect... Oh. Could expect function let if while return raw identifier open brace open parenthesis a literal okay. No formatter. I did not want you to do that. If let while return. There we go. That's why expected is a vector. Oh, that's what I was using expected grammar error for. I'm gonna parse this sum t self next. This is an expected any. This is just a end of file error, and I'm guessing that parse pattern. Oh, I'm not using this code at all. I'm not parsing patterns right now. I might need to do that in the future, but for now, I'm not going to refactor stuff that I already know I'm going to rewrite later. Value path is the only thing I care about left. It's the last thing in the file. Now we have to go up to fix the errors here. Figure out if that's the actually how we want to do this. This is how I want to do that. That's really easy. Also really easy there. No way, it was really that few references. Okay. Nice, okay. That was the majority of the pain there. Aside from runtime errors, which are going to be more painful. Like a lot. But hey, now when I have parsing errors, they don't suck ass. Which is good, because they did before. By a lot. Because I'm not doing the source BS anymore. I can just not map it. We can do literally just do path source like that. It should work. That should be good. This into a Lexer error, and the Lexer error will just be unexpected char. Look at that. Nice. Makes it so much cleaner. I wish I could make those automatic, but I can't. Sun is starting to light up my room a lot. That's the eyeballs a little. Even with my dark mode becomes light mode. Okay, I think the only errors left will be in main. Yep. Wait, I want to do ANS. There we go. Parsing and Lexing now have better errors. Lexing has the same errors, but parsing now has significantly better errors by a lot. A ludicrous amount. Mystic source be gone. There we go. Okay. Okay. Might work now. Might work now. Missing field code. Okay. I'm just going to not have code be a member of the standard library yet. Formatter, please cease. Okay, whatever. There we go. That is working. So let's see it not work. Or fail gracefully. If I do that... Zero through 26 is beyond the end of... Implementation ranges behind that. Panic, panic, panic. Then... Parser. Error mod rs. Render mod rs. So we want to look at error mod rs. Could do 7. Oh, here it is. Why does it just panic instead of giving me a reasonable string? Why doesn't this have error checking? So this is in... Render mod rs 227. Render mod rs 227. Oh wait, no. Hit snippets. Render mod rs 156. So it's here. this means is here I need to assert that snippet text. Here, the range. End is less than or equal to text dot length. And this can be +1 to go past the end. I just wanted to catch the assertion here instead of there. Yeah. Then maybe I'll hook up a debugger. Try to catch it. Yep, that assertion failed. To display range does not fit in snip. Okay, so range not fit in snippet text with length snippet text length. I'll implement things, so we'll just debug, print it, and then we're good to go. That should be all the data I need. Okay, let's see. Range 0 to 26 does not fit in snippet C. Length 1. Fuck. It's been so long since I wrote this code. I have no clue. a clue how to fix this. Working when I last used it. That span is definitely wrong. Range. Where are we getting range from? A. This is the snippet. This is the annotation. This is the annotation, span, get range, store. Set end. Yep. Range. Where's the last place that I got a range? There. A span equals VM span create a range start minus this snippet annotation. This is a snippet. And get range to native. I'm just gonna look at my old code and see what the fuck it was doing here. Because I do not want to have to reinvent this function, please. So it'd be emit, snippets, current snippet. Basically what it's trying to do is if there's multiple snippets for the same line, you don't want to have to display multiple lines. Snippet. What is a annotation clone? Cloning the entire annotation. Bubbles. Why am I cloning that? Spans aren't identical. We start a new snippet. Pretty understandable. I don't think that's broken. Code, file path. That's the only place file path is used. Yeah. We'll just put it in there. source text, code, cursor. Let's see how cursor is being defined. And I think cursor is a class that I defined. Use self at all? It doesn't. Let's just... These not be part of the function. They're just utilities. How does this work? Returns a text position, takes in a range start. A span range start. Returns a text position. Is the start of the line? Let's create some documentation here. Buffer index. So the index within the entire buffer. To chart index. Is the current cursor. Can I just iterate this in reverse, though? Then again, I wouldn't know what... I wouldn't know what line number it is. And all. So I broke this somehow, or maybe it was already broken and I don't know. First line of the file breaks it. It'd be really funny if it was just that the first line breaks it and nothing else. Move 051 does not fit in the snippet standard IO with length 5 stack backtrace. Okay. Um, just creating a new span with a range. I don't think that's correct. That seems wrong. This is the code right here. Range start cursor buff index cursor. Yeah, this is just straight up wrong. Let's see all the other places. See this. A.span equals start equals span range start. S equals current snippet azimuth unwrap. Range start, a range end, a range start. Would that one line have been enough to make the entire difference? I don't think so. Well, let's see. Range 551 that does not fit in snippet is nothing. It made it worse. Fine. Shouldn't this not be... span range start S range start A range end S range start. Yes, that is correct. Patience push end line cursor line. Next line was advanced lines 1 cursor source text. I assume source text is working, right? Could debugger this, but I don't want to. Let's see. How do we... I never debug cursor. Cursor line is less than... Cursor.line is less than that end line or cursor line. Current snippet is none. I have no clue what I'm trying to do there. Set the combined range there. Oh wait, this is supposed to be S-span, not A-span, S-span. Annotation span. Why am I ever affecting the annotation span? Ever. Is A-span affected by... So A is a local copy that shouldn't affect anything, right? Anything. A clone, annotations push a clone. Annotations push a clone. So this is where that span is having its effect. Okay, okay. So that single letter there from A to S probably fixed it. Yes. Yes, so this error right here, this is our code generating the error in displaying it. Amazing. Okay, time to delete every single one of those print statements. Try messing with this more. I just put a semicolon right there. Yep. Then it does my entire list of things that it's expecting. What if I do that? Expected identifier. Very nice. What if we have a function where we just put a comma instead of a thing? That works again. Expects expression. Nice. Okay. Yeah, so errors? Errors are working how I expect them to. So I'm gonna commit this. if that ever loads, which it doesn't seem like it's going to. Goodbye, Vim. Okay. What did I do? After error handling to copy brain C emitter. There we go. Okay. I think that's enough coding for today. It's time for me to play Marathon. Okay. Yeah. Very good progress. Basically none, except for I can actually tell what goes wrong when the parser fails. So, yeah. Now it's just time to do that for runtime errors as well. So when like function calls and whatever fail, it will be really easy to implement that now because our expressions actually have spans that tell us where they came from. Now, thinking it would be really cool if values also referenced where they were initialized. I don't know how useful that feature would be yet, but I'm thinking about it. Thinking about it a lot. So, progress. I will see you guys